Welcome to the Math Path. Here we are. We're going to do this making the same one more time. We've actually got a setup. We've got the preparation. We've got the colors. Yeah, look. So each different color is the land of being measured by a different thing. Okay, and we're totally changing the problem. If you solved the old problem, good for you. You're very smart. We made a new problem, a whole new problem. Okay, so Annabelle is going to explain this because I decided maybe the magic of the Math Path videos is watching the kids figure it out on their own in real time, something that they seriously are learning, not a dramatization. So anyway, so here we are with this, but first of all, Annabelle, say hi to everybody. You want to explain what we're going to be doing?
Well, we're going to be making these the same, and we have to bring it through these globs. If we want to move them, we have to bring them through a special tunnel, and that tunnel will make them turn into different numbers. And
different amounts.
I take this 2, and I take away 1, and I put it through the measure by tunnel.
Okay.
Underneath.
Maybe let's put. Okay, so it goes through the tunnel. Vroom. And then where are you going to have it come back up
I'm
at?
going to have it come back.
How about right here?
Right here.
Okay.
And
What'll it be then?
Be 2.
It'll pop through. Pop back up as 2. That's true. That's true, Annabelle. You got it. If you had 1 measured by 2, that's what? The same as 2 measured by 4. Okay, now I hope we didn't, did we put everything back how it was?
Yep.
Okay, so first show over here what we're gonna, in the simple way, what we're gonna be doing. We're trying to make the same. What does that mean, to make them the same? We have...
That means that none of them have more and none of them have less. They just all have no more and no less, so they all have the same amount.
And we have to do it how? We have to do it, we can't just make anything disappear or come in. We're going to use the same globs, or this same, in this case it's just the same globs. In this case it's going to be the same number. Okay, we're going to use the same, and just rearrange them. We're just rearranging to make it the same. So let's see, how do we do it in here? This is what?
2
and
4.
Yeah, and we just...
So we're going to take this up to the top, these 2, and say, well, we have to put them in equally, which means put them in, not just putting both of them that we took away from this one and put up here. We can't just put both of them right here, and we can't just put them both back. We have to do something differently. And so we could put 1 right there and 1 right there. And then look, it's equal. It's the same.
Yay! Okay. Good. So now we're going to do the same thing with this. This is a whole bunch of numbers, which a number is one amount measured by another amount. And so that's what each of these 4 things are. And we're going to have 4 trains still. We're going to keep it 4 trains, although we can change the measures within the trains, and we're going to try to get them equal. And let me tell you a little secret, okay? I don't think I've really told you this before, clearly, but if you're getting confused, one thing you can do What's the easiest number to measure by?
1. So you just
Oh,
make
yeah,
them all
1.
measured by 1.
You already knew that. Yeah, exactly.
Because you told me.
Oh, I did tell you, and you remembered. Wow, that's amazing. So, I thought I had told you, but I thought maybe you didn't remember because I think I just said it down by the river. Okay, down by the river.
No, you didn't.
By our van.
You didn't
Okay.
tell me down by
I
the
thought
river.
that's okay. Well, I told you then too.
You
Okay,
told me right here.
right here. Okay, so so that's one thing you can do. If you can change things to be measured by 1, if you could make everything go through the tunnel and be measured by 1, that would make could make your life easier. But there's a lot of different ways to solve it. So we're just gonna sit here and let's watch as you solve the puzzle, and maybe we'll come over here so we can see it from your perspective. Ready? Go, and talk us through of what you're doing too. You can talk all about it.
I think I'm gonna figure out how many each one is, because if I don't know how many there are, then I'd just be doing crazy stuff, not knowing how many globs there were.
That's a good point.
And I have to figure out how many there are. And one here.
These are all labeled because Caleb went through and labeled them all with numbers.
32.
Yeah, 32. So each glob now has an identifying number, which, as far as I know, will not be useful at all for this problem. See, not everything is always useful. Some things you can just ignore.
12.
Okay. Okay.
And 3.
Okay, good job. Yeah, so I will make a little comment. So the interesting thing with doing it with numbers, with different measures, when you have numbers with different measures, you can't even know from just from the mystery amount, which how many globs are in the mystery amount, which one is bigger. Because look, these are both 12 as the mystery amount. Are they both the same?
No.
Why not?
Because they're measured by different things.
Right. And so we know they're not the same. They couldn't be the same. If they're the same mystery amount and a different measure, it can't be the same.
4 and take away 2, then there would only be, let's make it shape, 8 here if we put some in the measure. And there will be 10 here. So, they're not the same.
Oh, okay. You're just doing that to demonstrate they're not the same. That is true. Definitely not the same. Yeah. That's a good way. That's a good way to explain it, really. Yeah. Because that 2 that you're taking away and that 4 that you're taking away, that's the same, right?
Yeah.
That is the same thing. They're both one full measure. Okay. So let's see what we can do here to figure this out.
So, I am going to...
Maybe I will go back over here. Ah! Do you notice how quiet it is? Everybody's gone to the Bluegrass Festival, except for us. So we're having a nice quiet time. Where did you take that one from? Okay.
here. And one less there. So we
Here, can I give you an idea
yeah.
of what to do? You know what? I have a good idea. Here, is it okay if we bring this back through the tunnel?
Okay.
Because it's my idea. That won't necessarily be helping us. So it pops out of the tunnel, whoop, and then when it comes back up, it pops up as a 1 into measure by 2 land. Okay, so you don't have to pop the little, each a train then through by train cars, one by one by one by one. What if you tried to figure out the whole thing all at once? Let me give you an idea of something you could do. See what you think of this. See if this gives you any ideas. What if you arranged them like this? Okay.
This one has basically 3 more than this one.
Okay. So how many does this one have?
That one has 12, and that one has 12.
Right.
But if you are making each one of what they're measured by a 1, like if this 2 was a 1 and these 4s were each 1, then you would have 3 of these and 6 of these. So if you took away 3 from this, there would be 3 left. And so
Okay.
this one has 3 more than this one.
Okay. How about this one?
That one has this one has 3 ones.
Now, if you were looking at these 3, by the way, are there any of them that are the same?
Those 2 are the same.
They don't look the same at all when you first saw them, huh? But it turns out they're actually the same, aren't they? Okay, let's do something with this last one. What can we do with this last one?
These 2, if they just somehow went away, which they can't,
Uh-huh.
then those 3 would be the same.
Well,
But those 2 can't magically go.
You have
no,
a right.
They wouldn't be the same.
Oh, but you had a good idea. I know why you were thinking that. Why wouldn't they be the same?
Because I forgot that this wasn't measured by 10.
It's measured by what?
8.
Right. Okay. So, what can we do here? What can we do?
Make them all into 8s, like we already made everything else into their proper number and shape. So we have 4 8s.
Okay.
So now we have 6 here of these, not just ones, because I'm sure that there are 12 actual logs, but we're just talking about how many of these there are. choose there. And there are 3 here, 3 here, and 4 here. So, we need to figure out how to get rid of 8 of these, or we could just totally make these not the same if we want. So,
You can do it do it any way you want. Do it any way you want. How could you make them all the same as measured by whatever? I mean, you could just change them all to be over by in number 1 land if you wanted. By the way, you can move the whole train at once. Just the whole train could go through the tunnel.
I knew that.
Do you want to do that? Would that make things easier? Or
Yes.
how do you want to do it? Okay, well, being easier is good, right?
Yeah.
Okay, so if you moved that one, where there's 6 measured by 2, all over to measured by 1 land, do you want me to help you? Through the tunnel. Okay. Then it comes back up. How?
12.
This is where you got to be very careful. You're taking them as 6. You said it was 6 if this was your 1, and now it is 1. If this was 1, it would be 6, and now it is going to be 1. So how many is it going to be?
What? It's going to be 6.
Right, yeah. So bring them, stick them right here on the red piece of paper. Red for 1.
Oh, I was taking away these ones, but you're taking them away.
Oh, okay. You're taking them away? Okay. Alright, so there we go. So we're going to have, now we got 2 trains. And now we can very clearly see which one is bigger, by the way. Okay. So, what do you want to do next?
Well, if we're taking everything away, then we'll still have lots of trips.
Okay. So, how many will there be when that one goes through the tunnel?
When that one goes through the tunnel, there will be 6 also.
Well, this is where you have to be very careful, because you've got the right idea, but sometimes when you're doing complicated things, it's easy to mess up. I mess up all the time too, as viewers of these videos can see
Will
and confirm.
be well, I split them in half,
Yeah.
and there is 6.
Well, I don't know why we split them in half though. Here, let's send 4 of them through the tunnel. Okay. We'll just do them one at a time. Maybe doing the whole train is too hard. If 4 of them go through the tunnel, okay, and then they come up through this tunnel, how many will be coming up? How many will it be?
2.
What will it turn into? This 4 that filled up that 4 perfectly will turn into 2 when it goes into the 1. Is that what you're saying?
No, did 1.
Just 1, huh? Okay, so the 4 turns into 1, and there it goes. Vroom. Okay. So that's going to be that train. Now what if we take another 4 through the tunnel? Whoosh. It goes down into this magic other land underneath the table. And then it comes back up. through the tunnel. It's 1 again? It's 1, okay. All right. And then it's the last 4. It's the last 4. Okay, let's send them through. It goes out. Goes out, and then it will come back up as what? Come back up as what? Do you know? What does it pop back up out as?
1.
Yes, 1. Whoa! Okay, so that's that whole train. And how many did it turn out to be?
3.
Now, does that actually make sense?
No.
That doesn't make sense to you? See, because we were doing the same, and this is a same within the same. So if we had this train over here, okay, let's steal some of these. If we have this train here in measured by 4 land, that's the same train as this train in measured by 1 land. Does that make sense? This and this are the same, right?
They're the same.
Does that make sense?
Yeah.
You have to keep it the same as it's moving between one measure and another, however you want to move it, okay? So anyway, now this one is gone, and it's over and measured by 1 land. What can we do with that very last one? How do we move it over to measured by 1 land? How many will it become?
Well,
Tell the kids what you're thinking, and then...
by 8. Then 1 will always come through. So there will be 3 over there.
Are there 3 8s then? Is that how many? Because yeah, you're right.
No. I just forgot about this 8.
Oh no, we ran out of
4.
space on the paper. Okay. All right, let's do it. Let's do it just all at once. If they all went over through, then how many will pop out over there?
I don't think we can do all of them underneath the table at once.
Okay, we'll just pretend. We'll be over top the table. Yeah, the clear table. They're floating here in Never Never Land anyway.
Underneath the table.
Yeah.
They're floating underneath the table.
Okay. Whoa. Okay, how many come back up? Do you remember? I hope we still remember. Okay. There we go. Now look at it. Now what do? We're getting so close. I hope our video doesn't run out. What are we going to do now?
Now we have to make them all the same. So we have to split them up equally.
Okay. So first, maybe cut them all off so they're the same as the shortest one. And then we have extra ones up there at the top, right?
Yep.
Okay. And then we have to distribute those out,
and so
deal those out
first
evenly.
I'm going to put 1 on each one.
Okay.
Just in case we run out.
Yeah, just in case we run out.
We did run out. But we got 1 on each one.
We got 1 on each one. What do we have here?
We have boys.
They're all 4s. So that's how we made the same. 4 trains, or 4 things with 4 each. 4 measured by 1 on each of them. If we would have left them on the things, we could have done it that way too. If we left them on the things, that would have been very complicated. But we would have had 32 as measured by 8. We would have had the next one measured by 4. We would have had 16 as measured by 4. Next one measured by 2. We would have had 8 as measured by 2. And then we would have had 4 as measured by 1. But we just made them all measured by 1, and I don't know. Do you think that made it easier?
Yeah.
You probably do too. But you can do it however you want, and it all works out.
Yep.
All right. Anything else?
Bye-bye.